chapter, this is sixth chapter from Geography, Physical Geography, Class 11 from NCERT. The name of the chapter is Landform and their evolution. Let's start. After measuring processes, we have their action on the earth material, making up the surface of the earth, and the geomorphic agent like running water, ground, groundwater, wind, glaciers, and wave perform erosion. It is already known to you that erosion causes changes on the surface of Earth. Decomposition follows erosion. First erosion happens, and due to erosion, decomposition happens. And because of decomposition too, changes occurs on the surface of Earth. In this chapter, we will deal with this landform and their evolution. First, start with the question: what is landform? In simpler word, a small to medium tract or parcel of Earth crust is called landform. If, uh, if a landform is a small to medium size part of the surface of Earth, if a landform is small to medium size part of the surface of Earth, what is landscape? So landscape is collection of landforms. So several areas landform together make up landscape, large tract of the Earth's surface. Each landform has its own physical shape, size, materials, and is a result of action of certain geomorphic processes and agents. Action of most of geographic processes and agents are slow and take a long time. Every landform has a beginning. Every landform has a beginning. Landform once found may change their shape due to consider action of geomorphic process and agent due to changes in climatic condition and vertical and horizontal movement of land masses. Either the intensity of the process or the process themselves might change, leading to the new modification of landform. Evolution of fair implies in stages of transformation of either a part of the earth or one landform into another, or transformation of individual landform after they have once formed. That means each and every landform has a history of development and changes through time. A landmass passes through a stage of development somewhat comparable to the stage of life, youth, mature, and old age. But two important aspects of evolution of landform. So let's see. In humid region, which receive heavy rainfall, running water is considered the most important of the geomorphic agent in bringing about the degradation of the land surface. There are two components of running water. One is the overland flow in general land surface such as the sheet. Another is linear flow as stream and river in valley. So one is general surface, another is okay. The most of the original landfall are made by running water. So running water is the most important cause of uh, making of landfall. Are associated with rigorous and youthful river flow flowing over a steep gradient. With time, stream channel over a gradient over steep gradient turns gentler due to continued erosion. So it is given due to continued erosion. So this is a steep. Saying that when running water falls over this like this, and gradually make this steep smoother. Gradually make this steep, and the water which flows is much gentler as compared to the water here. The time over due to continued erosion as a consequence lose their velocity and facilitating active decomposition. Okay, active decomposition. There may be a depositional form associated with the stream flowing over the steep slope, but these phenomena will be on a small scale compared to those associated with rivers flowing over medium to gentle slope. Gentler the river channel, gentler the river channel in a gradient or a slope, greater is the decomposition. Okay, when the stream bed turns gentler due to continuous erosion, downward cutting becomes less dominant. When the stream bed turns gentler, let's say when the stream beds turn gentler, like this is almost smooth due to continuous erosion and downward cutting becomes due to continuous erosion. Like it is saying like this, the river beds become smoother. Gradually, it becomes smoother over time. Okay, and downward cutting becomes less dominant. So cutting of this surface, like riverbed, becomes less dominant with time, and lateral erosion of bank increases, and the lateral erosion of the bank increases. Okay, the bed is smoother, but lateral, like the bank of the river becomes the erosion of the bank starts when this becomes smoother. And the valley, as the consequences of valley and of hills and valley are reduced to plains, and due to this, valleys and hills are reduced to, like, they become plain eventually. In the incomplete reduction of relief of high landmass is complete reduction of relief of high landmass possible? Over time, it might be possible. Overland flow causes sheet erosion. Depending upon the irregularity of the land surface, the overland flow may concentrate into narrow to wide path. So imagine this is a like this color. So yeah. So because of sheet friction of the column or the, depending upon the irregularity of the land surface, the overland flow may be concentrated into a narrow part. Concentrated into narrow to wide part. So eventually, this is a narrow part. This becomes much wider. But because the shear friction of the column, because of the column of the water of flowing water, minor and major quantities of material from the surface of land are removed in the direction of flowing, and gradually small and narrow rills will form. So gradually, due to major quantity, so it is saying that the narrow rills, like these are small kind of holes on the surface. These and the water is the land masses are removed in a direction of flow, and gradually small and narrow rills will form. Because of shear friction of the column of flowing water, minor or major quantity of material from the surface of land are removed. Like these are due to just friction, due to sheer force of water flowing. There's some minor degradation of land will form. This small degradation, not degradation, it is called as when our major quantity of surface, like surface of land is removed due to water pressure, and the thing which is being removed, and these small things are called, basically, yes, these small things are called reels. These reels will gradually develop into long and wide gullies. So when these reels become bigger, it becomes gullies. These are basically gullies. And gullies, and further deepening and deepen, and the gullies will further deepen and widen and lengthen, and this is not good thing. This these reels will gradually develop and long gullies will be further give rise to network of filing. In the earlier stages, cutting down dominant dominates while during which irregularities such as waterfall and cascade will be removed. In the middle stage, stream cuts the bed slowly, and lateral erosion of the valley sides becomes severe. after liquefaction. Gradually the valley side are reduced to lower and lower slopes. So cutting of rock becomes lower due to cutting of rocks. Actually, it will look like this. So it will look like this after some time. Lower and slope. The divided between regions are likewise lower until they are almost completely flattened, or finally a lowland of faint reef with some low resistance remnant monad knocks standing out there, and these types of plain forming as a result of stream erosion called peneplain. 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 Okay. Almost. Peneplain means almost plain, like surface like this. And these are called monad. Knots. Monad. You stream are few during the stage with poor integration and flow over original slope with shallow V-shaped valley with no floodplain or very narrow floodplain along the trunk stream. It is saying during the youth stage, it will look like this. This V-shaped valley with no floodplain or very narrow. This is a very narrow. So this is basically a floodplain where the water goes so narrow. Floodplain. Along ground. The stream divides are broad and flat with marsh and swamp and lakes. Meander, if present, develop over this broad upland surface. These meanders may eventually entrench themselves into uplands. These meanders of uplands, okay. These meanders may eventually entrench themselves into uplands. Waterfall and rapids may exist where hard rocks and bodies are. Waterfall and rapids may exist where there is hard rock or bodies are exposed. So basically, the rock where hard rocks are there, hard rock which which takes a long time to get erodes. They will in there like water or rapid. Waterfall will occur in those places where hard rocks are formed, basically. And where soft rock, no, like basically surface of the land is there where hard rock is not there. It will form plains. Eventually, it will become plains. Let's see. Nature. During this stage, the stream are plenty good with integration. The valley are still V-shaped, but deep. V-shaped but still deep. Trunk stream are broad, so not V-shaped. It will be V-shaped, but like this V-shape. So this is still V-shaped, but it's broad, unlike this. Broad. Stream trunk are broad and enough to have a wider floodplain within which stream may flow in meanders. It might flow like this, confined within the valley. valley like this. Look at this. Uh, and confined with the flat and the broader interstream areas and the swamp and the marsh and youth disappears and the stream divides turns sharp. The waterfall and rapid disappear. So in this version, waterfall is there. And rapid. No. Waterfall. Older, like old. Small tributaries during old ages are with gentle gradients. Like these gradients will be very gentler. And uh, stream meanders freely over vast floodplains, showing natural leaves like this one. There is water. And oxbow lakes divides are broad and flat with lakes, swamps, and marsh, and most of the landscape are at slight above sea level. Erosional landform valleys start small, narrow rails will gradually will develop into long and wide gullies. We have already will gullies, and the gullies will further deeper and wider and lengthen to give rise to the valleys. Okay. Depending upon the dimension and the shape, many of the types of valleys are like V-shaped, gorge, and canyon, and can be recognized. A gorge is a very deep valley with very steep to straight line. A canyon is characterized by steep step-like slope. Canyon. This, this, this is basically a canyon. Okay. Gorge is a very deep. Okay. A gorge is equally. Maybe I think a gorge is almost equal as its width is almost equal in width as top as bottom. Like so, basically it's saying like this: its bottom is as equal to its top. This is basically a gorge. In the contrast, a canyon is wider at the top and than its bottom. In fact, a canyon is a variant of gorge. Where valleys depend upon the types and the structure in which they are formed. For example, canyon commonly forms in horizontal bedded sedimentary rocks, and gorge are formed in hard rocks. Okay. So here we got gorges. Gorge is basically formed in bedded sedimentary rocks, horizontally bedded. Canyon. Canyon welcome. Bedded sedimentary. It is formed in hard rocks. that's why it takes a long time to erode. It takes a long time to erode because it is a hard rock and takes less time to erode and hence forms like gentler steeps. Potholes and plunges. So, over the rocky bed of a stream, more or less circular depression is called potholes. Rocky bed of a stream, more or less in a circular depression is called potholes from because of stream erosion aided by abrasion of rock fragments. Abrasion of rock fragment. Slit is forming due to abrasion of rock fragments. Once a small and shallow depression forms, pebbles and boulders get collected into those depressions and get rotated by flowing water, and consequently the depression grows in dimension. A series of such depressions eventually joins, and the stream valleys get deepened. Stream valleys get deepened. At the foot of the waterfall, also large potholes, quite deep and wide, forms because of sheer impact of the water and the rotation of the boulder. Such deep holes, large and deep holes at the base of the waterfall is called plunge pool. This is self-explanatory. Insides and entrance meanders. Basically, meanders is like this. In stream that flow rapidly over steep gradients, normally erosion is concentrated at the bottom of the stream channel. Also, in case of steep gradient, lateral erosion on the side of the valley is not much as compared to the stream flowing on the low and gentle slope. Let's read it once again. In stream that flow rapidly over steep gradients, normal erosion is concentrated at the bottom of the stream channel. Okay, bottom of the stream channel. Also, in those cases of steep gradient stream, lateral erosion on the side of the valley is not much as compared on the sides. Is not much. Lateral erosion on the side of the valley is not much compared to the stream flowing on the lower gentler slope. So it is saying like this is a steep valley. Okay. So in steeper valley, this is a steep valley. It is saying that the erosion mostly occurs in this at the lower part of the hair. Here mainly that erosion occurs because the steep is too much steeper than gradient but whereas the steep is gentle like this one, it is saying that the most of the erosion part will occur at the sides, like at the upper portions. In this lateral erosion occurs not much as compared to flowing on the stream flowing on the low or gentle slope. Because of the active lateral erosion, stream flows over gentle slope develop sinuous and meandering core. Sinus and meander. So in gentle slopes, like in slope like this, mainly there is a like this. It forms river goes like this, or stream goes like this in this direction, in this direction, in this direction. this direction. This mainly occurs in this gentler slopes. It is common to find meandering course over floodplains and delta plains where stream gradients are very gentle. So it is common, very deep and wider meanders, like very deep and wider, can also be found cut in hard rocks. Such meanders are called incised or entrenched meanders. Like when this is happening in hard rocks, what meandering? Like meandering is when meandering is found in hard rocks. It's called incised entrenched meandering. So this could be an example. No, this could be an example. This is an example of this one. Here is meandering is happening like this all meandering. Okay, let's move on. River terrace. River terrace are the surface making old valleys floor or floodplains level. Are surface making river terraces are surface making old valley floodplain levels. So it's basically saying that it makes plain. They may be bedrock surface without any alluvial cover or alluvial terrace consisting of stream deposit. River terraces are basically product of erosion as a result due to vertical erosion by stream on its own depositional floodplain. There can be a number of such terraces at a different height, indicating former riverbed levels. The river terrace may occur at same elevation or on either side of the river, in which they are called fair terrace. This is an instruct. I'm not getting exactly what he's trying to say, so I will mark this red so that if I visit this, when I visit this, I will get a complete answer about this. Alluvial fans. Depositional landforms, alluvial fans. Alluvial fans are found when flowing from high level stream flowing from high level breaks into foot slope plains of low gradient. So it is saying that when the stream are flowing from high level, this is a mountain. Then this is steeper, and now the slope gets gentler. The deposits. This is a river. Now the deposit from there, it's taking deposit with it. And making this deposit like deep water, and making kind of deposition of, and making just read this one. Once I read this, I need to explain. Breaks into foot slope plains of low gradient. Normally very coarse load is carried by stream flowing over a mountain slope. This load becomes too heavy for the stream to carry it over the gentler gradient and get dumped. and spread as broad low to high cone shaped deposit called alluvial fans. Okay, here we have an example. Alluvial fan deposit I held on the way to Amarnath and Jammu, Kashmir. So let's imagine that water is flowing from it and it's taking a part of land with it. Like they are not finely like some abrasive part, like small rocks and all, which are not smooth. They are coarse. They are coarse, very coarse load. See, very coarse load. So when this load becomes too heavy for the ship to carry and get dumped, and over gentler gradient and get dumped and spread as broad low to high cone shape. Deposits called alluvial fan, usually stream which flows over fan, are not confined to the original channel for long and shape their position and across the fan, forming many channels called distributaries. 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 Okay, distributaries. Smart. Alluvial fan distributaries. Basically, is saying that when rivers, oh, like imagine this is a river, and so it is forming a kind of channel, multiple channel, multiple channel, multiple channel. These channels are made due to like when the material when the coarse material get deposited here, it causes it will yes it will usually which flows over the confined to the mentioned. Yeah, it will not. It will once it get deposited here. This channel is blocked. Now the river flows in this way. And now again, if this channel is blocked, it will change its direction. So this type of channels it form. This this whole thing is called alluvial fan. Okay. Deltas. Deltas are alluvial fan but developed at different locations. The load carried by the river is dumped and spread into the sea. If this load is not carried far away into the sea or distributed along the coast, it's spread. If this load is not carried away far into the is not carried far into the sea or distributed along the coast, it's spread and accumulates as a low cone. As a low cone, unlike in alluvial fan, deposit makes up the delta very well sorted and clear. Unlike alluvial fan, the deposit make up delta very well sorted, very well sorted with clear stratification, and the coarsest material settle out first, and the finer fraction like salt, clay are carried into the sea. As the delta grows, the river distributaries continue to increase in length. As the delta grows, the river distributary continues to increase in length. Delta continues to build up into the sea. So it's also the same, but here, here it, earlier fans are basically made of mountains, plus river. But deltas are basically the same, but deltas The river don't have that as much coarse material as the mountain, but it has some coarse material, and it also forms it also changes channel due to that deposition of that material, but it's not as much as the alluvial banks. So here the coarse materials, when they get deposited, like here, just like veins. So but and it get like ultimately it get this this all get connected into the sea. Okay. So river plus sea. Sea makes up the delta. The river is tributary continues to increase in length and the deltas continue to build up into the sea. Floodplains, natural leaves and point bar. Deposition develops a floodplain just as erosion makes valleys. So these are okay. These are floodplains. Deposition develops. So deposition makes just deposition develops the floodplain as erosion makes valley. Erosion cuts and makes valley, whereas decomposition like it fills up and makes floodplain. Floodplain is major landform in river deposition. Large size materials are deposited first when the stream channel breaks into and when the stream channel breaks into gentle slope. Thus, normal and fine sized material like sand, slate, clays are carried by relatively slow moving water in gentler channel, usually found in plains and deposited over the flood. And when the channels spill during flooding or over the bed, a river bed is made of deposition. In the active floodplains, the floodplains above the bank is inactive floodplain. Inactive floodplains above the bank basically contain of two types, like flood deposit and the channel deposit. Flood deposit only happens when there is an overflow of water, and channel deposit like basic deposit the like all the substance which is all the time carried by river. In plains, channels shifted literally in plains. Channels shift literally and change their course occasionally, leaving off leaving cut off courses which get filled up gradually. Such areas over the floodplain built up by abandoned or cut off channel contain coarse deposits, and the flood deposit of still water carries relatively finer materials like slit and clays. The floodplains in delta are called delta plains. Natural leaves and point bar. So this natural leaves, natural leaves. These are natural leaves. These are natural leaves. Okay, no. Okay, these are natural leaves. The outer portion, I think the outer portion is called natural leaves, and the inner portion. No. It's not like that. Okay. These point bars. Natural leaves are just one step, but in point bar there are multiple steps. As I can see, there are multiple steps. Just read it, and we will get the gist of it. Some found and associated with okay, natural leaves and point bars. Some of the most important landforms found associated with floodplains. Natural leaves are found along the bank of large rivers. natural leaves are found in large rivers. Hmm. They are low, linear, parallel ridges of coarse deposit along the bank of river, quite often cut into individual molds. Point bars, also known as meander bars. So these are point bars, also called meander bars. They are found on concave side of the meanders of large rivers and deposit are sediment deposited in a linear fashion by flowing water. Uh, concave and sediment deposited in a linear fashion by flowing water along the bank. They are almost uniform in profile and in width and contain mixed size of sediments. Why, in what way natural leaves differ from point bars? Okay, let's see. Meanders. In large flood and delta plains, rivers rarely flow in straight course. Loop-like channels called meanders develop over flood and delta plains, like these. Meanders is not a landform, but only a type of channel. So, meander is not a landform, but merely only a type of channel pattern. This is because of propensity of water flowing. Propensity. Oh, this is propensity of water flowing over gentler gradient to work laterally on the bank. Un- uncons- Unconsolidated nature of alluvial deposit making up the bank with many irregularities which can be used by water exerting pressure laterally. More thing is correllos, corri, correli, correllosis, corri, correllosis. This is from corri and correllos, force acting on the water acting on the fluid water, deflecting it like deflecting the wind. And when the gradient of the channel becomes extremely low, water flow leisurely, extremely low, leisurely and start working laterally. Slight irregularities along the bank slowly get transformed into small curvature in the bank. The curvature depends due to erosion along the bank. Erosion along the bank on the outside. If there is no deposition and no erosion or undercutting, the tendency to meander is reduced. Normally, in meanders of large rivers, there is an active deposition of concave banks. So the concave banks, this is the concave band. So active decomposition, here decomposition happens, here decomposition happens, here decomposition, active decomposition happens in the concave side of the concave side. Normally an active decomposition on the concave side. Concave, is this the right one? Concave. Yeah. Concave. Okay. Concave band undercutting the convex and undercutting along the convex band. The concave band is also known as cutoff band. The concave band is also known as cutoff band. Which show up as a steep scarp, and a Wax bank presents a long and gentle profile. So this is a shows a long gentler profile. This so I think what is happening here. So water is flowing in like this way. Okay. So it has more pressure in this way. It's applying more pressure. It's also applying some pressure, but the here. But when it applies pressure here, the deposition of materials is active here. But here, the decomposition matters. All the decompositions, like erosion of soils and the cuts from the bank of river, get deposited on the concave side and not on the convex side. So all the materials like which deposits, it deposits on the concave bank, and when it gets deposited here, like once all deposition happens until the route of the river is hindered, then it changes its routes. Now when it changes its routes, it forms a little, like it cuts off, it forms a oxbow lake. Cutoff bank is also shown as carbon profile is gentle profile. As meander grows into deep loop, the same may get cut off due to erosion at the inflection point and are left as oxbow lake. Now, groundwater. Here is the interesting, not interesting. Here the interest is not on groundwater as the resource, but our focus is on work of groundwater in erosion of land masses and evolution of land form. The surface water percolates well when the water is permeable. So he's saying that the surface water, like it passes through the rock easily when the rock is permeable, thinly bedded and highly jointed and cracked. These are all like giving the waterways to like flowing down, like to move vertically down. After vertically going down at some depth, the water under the ground flows horizontally to the bedding plane and joints and through the materials themselves. It is this downward and horizontal movement of water which causes the rock to erode. Physically or mechanically, removal of materials by moving groundwater is insignificant in developing landforms. That is why the result of work of groundwater cannot be seen in all types of rock, but in rocks like limestone and dolomite rich in calcium carbonate, and the surface water as well as groundwater through the chemical process of solution and deposition develop varieties of landforms. These two process of solution these two process of solution and precipitation are active in limestone and dolomites occurs either exclusively or interbedding with other rocks. Like they is saying that like there will be either a single types of rock or multiple rocks, like different rocks. Like this is a different type of rock, and this is a different type of rock. So It depends upon. So the next one is any limestone or dolomitic region showing typical landform produced by the action of groundwater through the process of solution and deposition called karst topography. So, what is a simpler answer? Like a simpler definition of karst topography? The process of solution and deposition is called karst topography. Okay. Any limestone or dolomitic region showing typical landform produced by the action of groundwater. Any shades of color. So, any limestone or dolomitic region showing typical landform produced by the action of groundwater. It's called karst topography. After a typical topography developed in the limestone and the karst region in the Balkan adjacent to Adriatic Sea, the karst topography is characterized by erosional and decompositional landform. The original landform: pool, sink, lapis, limestone pavement. Small to medium size, round to sub-round, shallow depression called or shallow holes. Okay. Form on the surface of limestone solution. Sinkhole are very common in limestone karst area. Sinkhole is an opening more or less circular at the top or funnel shaped toward the bottom, with size varying in area from few square kilometer to hectare, with wide depth from less than half a meter to 30 meters or more. Some of these form solely through solution, like due to solution, and others might start a solution form first, and if the bottom of a sinkhole forms from the roof of a void or cave underground, it might collapse, leaving a large hole opening into a cave or void below. Quite often, sinkholes are covered up with soil mantle and appears as shallow water pool. Anybody stepping over the pools would go down like it happened in quicksand in desert. The term doline is sometimes referred to as collapsed sink. Now this is important. Solution sink are quite common than collapse sink, and the solution sink is quite common than collapse sink. Quite often a surface run-off simply goes down shallow and sinkhole, and the flow of underground stream and re-emerge at a distance downstream through a cave opening. When sinkhole and doline join together because of slump and materials along their margin due to roof collapse and cave and long and narrow and wide trenches is called valley sink or overlast form. Gradually, basically is saying that once there is an underground stream and it leads to a path, leads to a place, and collectively when the sinkhole and doline join together, the sinkhole and the doline join together because of slump of material along their margin due to roof collapse of long cave, narrow wide trench is called sink valley. So don't go there. Gradually, most of the surface of the limestone is eaten away by the spits and trenches, leaving extremely irregular with a maze of point and grooves and ridge and lapis. Especially these ridge and lapis form due to different shell solution activity along the parallel to the sub-parallel joints. The lapis field may eventually turn into somewhat called limestone pavement. The caves. The areas where the alternating bed of rock, shale, sandstone, quartzite, wet limestone, and dolomites in between, or in areas where limestone are dense, massive, and occurring as thick bed, cave formation is prominent. The water percolates. The water percolates down either through the material or through cracks and joints and move horizontally along the bed planes. It is along these bed planes the limestone dissolves and long, narrow, and wide gaps called caves results. These can be a maze of caves at different elevation depending upon the limestone bed and intervening rocks. Caves normally have opening through which cave streams are discharged. Caves have opening at the both end, which called tunnel. Basic. Depositional landform. Many depositional forms develop within the limestone cave. The chief chemical in the limestone is calcium carbonate, which is easily soluble in carbonated water, that is carbon dioxide plus rainwater. This calcium carbonate is deposited when the water carrying it in the solution evaporates or loses its carbon dioxide as it trickles over the rough rock surface. Stalactite, stalactites, stalactites, stalagmites, 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 and pillars. Wow, this is a very stalactites. Okay, stalactites hangs as icicles in different diameters. Normally they are broad. Normally they are broad at their base and taper toward the free end, showing a variety form. Stalagmites rise up to the floor of the cave. In fact, stalagmites forms due to dripping of water from the surface through the thin pipe of the stalactite immediately below it. So it is like let me show you. Imagine this is a cave. So there's these type of things will be present from where water is dripped. Like water comes and drips from the edge of this, like water is dripping from there. And this is the ceiling of the cave which we are in right now. And these make something like these are called stalactites. Stalagtites. Stalactites. So now, in fact, it's very beautiful. And these are the one which are attached to the base, not the ceiling. It's called stalagmites. 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 Okay, in fact, the stalagmite is dripping of water from the surface or to the thin pipes of stalactites or thin pipes of the stalagmite immediately below it. So, as we can see, these are stalagmites and these are stalactites. Stalagmites. Wow. So, below it, stalagmites may take the shape of column disc, with a smooth, rounded bulge head, or miniature craters like depression. The stalagmites and the stalactites eventually fuse to give rise to column and pillar of different diameters. For glaciers, masses of ice moving as a sheet over the land, continental glacier of Piedmont glaciers. If the vast sheet of ice is spread over the plain at the foot of the mountains, or as a linear flows down the slope or the mountain in broad like valley, mountain or glacier are called glaciers. This is basically this is glacier. It is moving at the foot of the mountain. Glacier move basically because of the force of gravity. The movement could be a few centimeters to a few meters a day, more or less. We may have many glaciers in our country moving down the slope in valley, Himachal, in the valley in Himachal, higher, re, higher reaches of Uttaranchal, Himachal, Jammu, higher reaches of Uttaranchal, Himachal, Jammu, and Kashmir are the place to see. Do you know where one can see river Bhag, Bhagirathi? Bhagirathi is River Bhagirathi is basically fed by meltwater from under the snout Gamuk of Gangotri Glacier. So it is saying that the river Bhagirathi is made from Gangotri Glacier. In fact, Alkapuri Glacier feeds the water to Alkananda River, and the river Alkananda Bhagirathi joins to make river Ganga near Deoparag. So we have, let's write this down. So first of all we have, Gangotri. So there is a Gangotri. Gangotri. Gangotri Glacier, Glacier makes Bhagirathi River. Bhagirathi River. River and Alkapuri makes Alkananda River. And when together they makes Ganga. Together they make Ganga near Deoparag. Erosion by glacier is tremendous because the friction caused by sheer weight of the ice. The material plucked from the land by glacier usually lasts side angular blocks and get dragged into the fluid or side of valley, causing great damage through abrasion and plucking. Glacier can cause significant damage to uneven weathered rock and can reduce high mountain into low hills and plains. Glacier continues to move, divides get removed, divides get lower, and eventually the slopes get reduced to such an extent that the glacier will stop moving, leaving only a mass of low hill or vast outwash plain along with other depositional features. Like, see this one, depositional features. Figure 11 and 12 show glacier erosion and decomposition form described in the text. So some glacier and depositional form are rapid modified. So erosional landform, creeks are the most common landform in glaciated glaciated mountains. Creeks quite often are found at the head of the glacial valley. The accumulated ice cuts the critic while moving down the mountain top. They are deep and very wide trough and base with very steep concave to vertical dropping high walls in at its head well. A lake of water can be seen quite often within the creeks after disappears. Such lakes are called creeks or lakes. There, there can be two or more creeks in one leading another down below the steep. Horns and serrated ridges. Horns form through a headward erosion of creek walls. If there is three or more radiating glaciers cut headward until the creeks meet, high and sharp points and steep side are called horns. See what is called horns. Okay, these are called creeks. These are creeks. And creeks where there are three or more radiating glaciers heading. Okay, the divides between creek sides and head walls get narrow because of progressive erosion and turn into serrated or sawtooth ridges, sometimes referred to as RT, RTS, RTS with very sharp crest and zigzag outline. The highest peak in Alpine's Matterhorn and highest peak in the Himalayas, Everest, are in fact horns formed through headward erosion of radiating creeks. So the highest peak in the Himalayas, the Everest are in fact the highest peak in Alps, that is Matterhorn, and the highest peak in Himalayas, Everest, are in fact formed through headward erosion of radiating creeks. Glacial valley and trough. The glaciated valley are trough-like but U-shaped or broad floor, relatively smooth steep slide. Valley may contain littered debris or debris shaped as moraines. With some swampy appearance. There may be lakes crossed out of rocky floor or formed by debris within the valley. There can be hanging valley at an elevation or one or both sides of the main glacial valley. The face of divided or spur of such hanging valley open into main glacial valley are quite often tourniqueted to give them appearance like triangular facets. Very deep glacial trough filled with seawater and making up shorelines in high altitude are called fjord, fjords, fjords or fjords. Basically, F is silent, so fjords or fjords. Depositional landform. The unassorted cores and fine debris dropped by melting glaciers are called glacial delta. So, let me show you. It is not present here. Not present here. much is left. Oh god, this is a very big chapter. Very big chapter. Let's continue this.
So now depositional landform and glaciers. The unassorted cores and the fine debris dropped by melting glaciers is called glacial till. Most of the rock fragmented in tills are angular to subangular in form. Streams formed by melting ice at the bottom and side and the lower end of glaciers. Like basically, this is a imagine this is a glacier. So it is saying that due to there is tills here, like this. These are tills. Like it, it will be at angle, not 90 degree exactly, but it will be at some angles. The tills will be at some angle to the glaciers. And due to this tills, some tills are made by rock that put some pressure on the glacier. And some amount of rock debris small enough to be carried by the melting water stream is washed down. So some uh, uh, rock debris from the tills will be carried by the glacier. And also due to friction, it will lose some uh, ice also from the glacier, and that ice will be converted into the stream. So like melting ice. So it will be both at the bottom of the glacier and at the sides of the glacier also. The stream which are melting from the glaciers. Such it will be carried melting stream will is washed down and deposited. What? The rock debris small enough to be carried by the melting stream is washed down and deposited. Such glaciofluvial deposits are called outwash deposits. When it's called what is outwash deposit? Right, the rock debris that got carried down or washed down by the water stream of the glacier. Uh, Such glaciofluvial deposits are called outwash deposits. Unlike till deposits, the outward deposits are rough and stratified and assorted. The rock fragments in the outwash deposit are somewhat rounded at the edge. So the rock fragment of in outwash deposit are somewhat rounded at their edge. तो इतना हो गया. Shows a few depositional landforms commonly found in glaciated areas. They are long. They are long. They are long ridges, moraines. Moraines. They are long ridges of deposit in glacial tills. Okay. They are long ridges. They are long ridges of deposits in glacial tills. Long ridges. Imagine this is a ridge and this is a till. The terminal moraines are long ridges or debris deposit at the end or at the end toe of glacier. Lateral moraines form along the side parallel to the glacial valley. Okay, the lateral moraine may join terminal moraine, forming a horseshoe-shaped ridges. So shaped ridges. There can be many lateral moraines on either side of the glacial valley. These moraines partly or fully owe their origin to uh, glaciofluvial water pushing up materials to the side of glacier. Many valley glaciers retreat rapidly, leaving an irregular sheet of tilts over their valley floor. Such deposit varies greatly in thickness and in surface topography are called ground moraines. Many valley glaciers retrieve many valley glaciers retrieve rapidly, leaving an irregular sheet of tilts over their valley floors. The moraines in the center of the glacial valley, flanked by the lateral moraine, is called medial moraine. They are imperfectly formed as compared to lateral moraine. Sometimes medial moraine are indistinguishable from ground moraine. Eskers. Okay, these are eskers. These are terminal moraine. Basically, as it said, they are kind of ridges, and the ridges which form shoe-shaped are called parallel to the glacial valley. Yes, it is parallel to the glacial valley. These are parallel. These are parallel to the glacial valley. And terminal moraine are okay. Terminal moraine are shoe-shaped ridges, like horseshoe shaped. Let me give you exactly like this is a shoe shape, and the ridges will be like this. This is a horseshoe ridge. This is a terminal moraine and horseshoe shape. Moving on, eskers. When glacier melts in summer, the water flowing on the surface of ice or steep down along the margin or even moves through the holes in the ice, this water accumulated beneath the glaciers and flow like a stream, a channel beneath the ice. Such stream flowing over the ground, not in the valley, cut in the ground, with ice forming at its bank, very coarse material like boulders and block along some mirror fraction of rock debris carried into this stream settle in the valley of ice beneath the glaciers. After the ice melts and can be found sinu- Senius ridge called eskers. So basically the particles like the rock particles or boulders which got carried out by the stream which is formed by the glaciers. So these all the materials, not all the boulders and the rock materials, they are deposited and they form a structure. When all the ice, all the water gets dried out, the structure is called eskers, and the structure is called ridged shape, like these. Like these are formed when all the ice and the waters get dried out in summer, and these are formed only due to the stream which carry out these materials which form these structures. Let's carry on. Outwash plain. The plains at the foot of the glacial mountain or beyond the limit of continental ice sheet are covered with glaciofluvial deposit in the form of broad flat alluvial flan, which may join to form outwash plain of great gravel, slit or clay or sand. So this is outwash. These are outwash plain. these are outwash, and when this particular thing when dries out, it becomes outwash plain. And yeah, basically that. Uh, Distinguish between river alluvial plain and glacial outwash plain. Drumlins. Drumlins are smooth oval-shaped ridges-like features composed mainly of glacial tilts with some masses of gravel and sand. Long axes of drumlins are parallel to the direction of my movement. They may be measured up to 1 kilometer in length or 30 meter or so in height. One end of the drumlin facing the one end of the drumlins facing the glacier is called stoss and is blunter and steeper than the other end, which is called the tail. So basically, it is saying, suppose this is a glacier, and it is saying that this front, this uh, this front is called stoss and stoss, and this is the tail of glacier. Okay, so the drumlin forms due to dumping of rock debris beneath the heavy load of ice through friction, through friction, and in to frictures in the glacier. The stoss end get blunt due to pushing by moving force. Okay, this end is get blunter due to as the glacier movement is this way. Okay, it is moving this way. So due to friction, it gets blunter. It doesn't get sharp. It gets blunter. Drumlins, drumlins give an indication of direction of the glacier movement. Okay, drumlin gives an indicator of direction of glacier movement. Wave. What is the difference between tilts and aluminum? So waves and current. Coastal process. Coastal processes are the most dynamic. Coastal processes are the most dynamic and hence more destructive. So, don't you think it is important to know about the coastal processes and forms? Some of the changes along the coast take very fast. At one place, there can be erosion in one season and deposition in another. Most of the changes along the coast are accomplished by waves. When waves break, the water is thrown with great force into the shore, and simultaneously, there is a great churning of sediments on the sea bottom. Constant impact of breaking waves drastically affect the coast. Storm waves and tsunami waves can cause far-reach changes in a short period of time than normal breaking waves. As wave as wave environment change, the intensity of the force of breaking wave changes. Do you think do you think about generating force behind waves and current? If not, refer to the chapter on movement in ocean. Yeah, let's see. Other than the action of waves and the coastal landform depends upon Other than the action of wave, the coastal landform depends upon configuration of land and sea floor, whether the coast is advancing, that is emerging seaward, or retreating, that is submerging landward, assuming sea level to be constant. The two types of coast are considered to be explain the concept of evolution of coastal landform. The first is high and rocky coast. Another is low and smooth and gentle sloping sedimentary coast. High rocky coast. Along the high rocky coast, the river appears to have been drawn with high highly irregular coastline. Along the high rocky coast, the river appears along the high rocky coast. The river appears to have been drowned with highly irregular coastline. Okay, got it. The coastline appears highly intended with extensive. The coastline appears highly intended with extension of water into the land where glacial valley fjords are present. The coastline appears highly indented with extension of water into the land where the glacial valley, that is fjord, is present. The hillside drop off sharply into the water. Shore does not show any depositional landform initially. Erosion features dominates. Along the high rocky coast, waves break with great force against the land, shaping the hill's side into a cliff. With constant pounding by the waves, the cliffs recede, leaving a wave-cut platform in the front of the sea cliff. Waves gradually minimize the irregularities along the shore. So gradually it makes the cliff smoother. What the waves gradually make the shore smoother. The material which fall off and remove from the sea cliff gradually break down into small fragment and roll into roundness and will get deposit in the offshore. After considerable period of cliff development and retreat of coastline turns somewhat smooth, as I said, with the addition of some more materials to this deposit in the offshore. At wave-built terrace, as a wave-built terrace would develop in front of wave-cut terrace. A wave-built terrace would develop into wave-cut terrace. As the erosion along the coast takes place, a good supply material becomes available to longshore current and wave deposit them as a beach along the shore as a bar, long ridges of sand and shingle parallel to the coast or in a near shore zone. Bars are submerged Bars are submerged features and when the bars show up above water, they are called barrier bar. Barrier bar which get keyed up to the headland of bay are called split. When the barrier bar and a split from the mouth of bay and block set, a lagoon forms. The lagoon would gradually get filled up by sediments from the land giving rise to coastal plain. Low sedimentary coast. Along Along low sedimentary coast, the river appears to extend their length by building coastal plains and deltas. Along the low sedimentary coast, the river appears to extend their length by building coastal plains and deltas. The coastline appears smooth with occasional incursion of water in the form of lagoon and tidal creeks. The land, the land slopes gently into water. Marshes and swamp may abound along the coast. Depositional features dominates when wave break over a gentle slope. When wave breaks over a gentle sloping sedimentary coast, the bottom sediment gets churned and and move readily building bars, barrier bars splitting lagoons. Lagoons would eventually turn into swamps, which would subsequently turn into coastal plain. The maintenance of these depositional features depend upon steady supply of material. Storm and tsunami cause drastic changes irrespective of supply of sediment. The large rivers which bring a lot of sediment build deltas along low sedimentary coast. The west coast, this is kind of important. The west coast of our country is a high, rocky, retreating coast. Erosional forms dominate in the west, and the east coast of India is low sedimentary coast. Depositional form of depositional form dominates in the east coast. So what is the various difference between the high rocky coast and the low sedimentary coast in terms of process and the landform? Erosional landform. Cliff terrace cave stacks. The wave cut cliff and the terrace are two forms usually found where erosion is the dominant shore process. Almost all sea cliffs are steep and may range from a few meter to 30 meter, even more. At the foot of such cliff, there may be a flat or gentle sloping platform covered by rock debris derived from sea cliff behind. Such platform occurs at elevation above the average height of the wave, called wave cut terrace. So basically, it is saying, imagine this is a cliff. It will be like this, and this is our. Imagine this is water level. This is the water. Sea. Basically, it is a sea, and this is a cliff. So occasionally, the water might hit this way. It will reach this level at the night, and it will hit this way. Sometimes it will hit this at this level. Sorry. Sometimes it will hit this way. Sometimes it will hit this way. So it will make it into a terrace. It will make it into a steps. And these steps will be a smoother due to water constantly hitting them. So where the force are applied? Force are applying at this side. That's why it has moved back. The intensity of the force will be applied at this side. At some time period, it will be applied at this side because because the sea level is this at this level. Sea level is decreased, and sometimes the sea level is at this part. Sometimes at this part at the night, basically. So at some different period of time, the sea will the wave will be like the wave will be striking the cliff at different areas. That's why it is forming a terrace. So the it is saying the average height of the wave, the such platform occurring at an elevation, such platform occurring this platform occurring at an elevation like this one platform above the average height of the wave. Above this is basically imagine this is the average height of the wave. So this will be called wave cut terrace. This will be called wave cut terrace. Lashing out of wave. The lashing out of wave against the base of the cliff and the rock debris that gets smashed against the cliff along with the lashing of creates hollow, and these hollow gets widen and deepen to form sea caves. Okay. So it is saying the constantly hitting of wave will break down this rock. Eventually, eventually it will break down this rock, this cliff, and it will break down and it will make a cave here. So this is called as sea cave. Along with lashing will create hollow, and this hollow will get widened and deepened from sea cave. The roof of the cave collapse and the sea cliff recede further inland. The retreat of the cliff may leave some remnant of the rock standing isolated at the small island just got off the shore. Such resistance of mass of masses of rock originally part of the cliff or hill is called sea stack. So it is saying sometimes due to making of cave, sometimes a part of the cliffs, like this whole rock, will get it gets broken down because due to making of this sea part, due to making of this cave. So structurally it doesn't have any base, so it will basically go down. This whole rock will go down, smashing the cave, like collapsing the cave itself. So now this whole mass will appear like this, and the area, it will like this whole stack of rock will go down, right? So this stack of rock will be called, when this happens, when the cave collapse, it is called sea stack. These hills are called, this will be called sea stack. Like all other features, sea stack are also temporary, and eventually the coastal hill and the cliff will disappear because of wave erosion give rise to narrow coastal plains. And with on rush of deposition behind from the land behind gets covered by aluminum and get covered by the shingles and the sand to form wider beach. Eventually, it will get it will get erodes, and after some time, this whole cliff will become a narrow plain. Not narrow, well, like it will become a plain after some time. Like after a huge amount of time, not some time, after a huge amount of time, it will become a good plain. Aluna may get covered up by shingles or sand to form a wide beach. Depositional landform, beaches and dunes. Beaches are characterized by shorelines that are dominated by the deposits, but may occur as patches along even the rugged shores. Most of the sediment making up the beach comes from the land carried by the stream, river, or from a wave erosion. Beaches are temporary features. Beaches are temporary features. The sandy beach, which appears to be permanent, may be reduced to a very narrow strip of coast pebbles in some other season. Most of the beaches are made of sand-side materials. Beaches called single beaches contain excessive small pebbles and even cobbles. So of beaches called single beaches contain excessive pebbles and even cobbles. Just behind the beaches, Just behind the beaches, sand lifted and winnowed over, winnowed from over the beach surface will be deposited as sand dunes. Sand dunes forming long ridges parallel to the coastline, and these are very common along low sedimentary coast. So basically, let's change the color. Let's take this. Let's take something yellow. Yeah. So it is showing it is behind the beach. These are dunes. Imagine this is dune. These are dunes, and here we have water. Not water. This is basically sea. Hmm. And we are having sea of C over here. This is C. This is dune. So this particular thing is called dune. Like this is dune, sand dune, or beach dune also. Sand dune forming long ridges parallel to the coastline. It is parallel to the coastline. Like imagine this is our coastline. So our dune will also follow this coastline parallelly. So these dunes are will be parallel to our coastline. So moving forward, just behind the beach, the sand lifted winnowed over. Okay. The sand dunes forming long ridges parallel to the coastline are very common along. These are very common along low sedimentary coast. Now, pass barriers splits. A ridge of sand and shingles formed in the sea in the offshore zone lying approximately parallel to the coast is called offshore bars. Basically, these are also called bars. A ridge of sand and shingle form uh, offshore in the offshore zone. Okay, not this one in the offshore zone. So this is dunes, but not here. But it is all the way back at the land. An offshore zone bar is exposed due to further addition of sand bar. The offshore bars and the barrier commonly formed across the mouth of a river or at the entrance of bay. Sometimes such barriers are get keyed up at one another at one end of the bay when they are called splits. Okay, these the reservoirs in the sea are formed. Okay. Wait. I was wrong. This was this was correct, and this has nothing to do with this one. The bars and barriers split. A ridge of sand or shingle formed in the sea. So these are formed in the sea itself. So these are formed in the sea itself, and also called these are also called parallelly. It are also parallel to the our coastline, like this one. And offshore which are exposed due to further addition of sand are called barrier bars. The offshore bars and the barrier commonly formed in the mouth of the river or at the entrance of the bay. So it is basically this is a bay and it is formed at the entrance of the bay. This one. Let me erase this. So this particular thing is called our offshore bar at the mouth of the river, and then sometimes such barriers are get keyed up into one another bay, and when they are sometimes these barrier bar gets keyed up to one end of the bay when they are called split. Splits may also develop attached to the head or to the hill. The barrier and bars and split at the mouth of the bay gradually extends, leaving only a small opening of the bay into the sea. So it is saying basically it is extended till the end. Sometimes when it's leave only a small opening, basically not here. It leaves small opening here. This is the small opening, not here. This is a small opening. So split so we make attached to sometimes develop to the handle. The barrier split at the mouth of barrier will get extend only small opening into the sea and the bay will eventually develop into a lagoon. So basically, this part is called lagoon. This is how lagoons are formed. Eventually develop into a lagoon. The lagoon gets filled up gradually by sediment coming from the land, from this one, or from the beach itself, aided by wind. A broad or wide coastline may be developed. A wide coast or a broad coastal plain may develop when this all waters get dried up. Dried up. Do you know the coastal? Okay, let's mark the screen. Do you know the coastal offshore bars offer the first buffer or a defense against the storm or the tsunami absorbed by absorbing most of their destructive force? Then comes the barrier beach dunes, and the mangroves, if any, to absorb the destructive power of the storm, tsunami, and waves. So, if we do anything which disturbs the sediment budget and the mangrove along the coast, these coastal form will get eroded away by leaving human habitat to bear the first strike of the storm and the tsunami. Okay, let's go to the next one. Wind. Wind is one of the two dominant agents in hot desert. Desert floors get heated up too much and too quickly because being dried and barren. The heated floor heats up the air directly above them, which results in the upward movement of the hot, lighter air with turbulence. And any obstruction in its path sets up eddies, whirlwind, updraft, and downdraft. Wind also move along the desert floor with greater speed, and the obstruction in their path create turbulence. Then the obstruction in their path create turbulence. Of course, there are storm winds which are also destructive winds causing deflation, abrasion, and impact. Deflation due to uplifting and removal of dust and smaller particles from the surface of rock. In the transportation process, sand and slate act as a effective tool to abrade the land surface. The impact is simply sheer force of momentum which occurs when sand is blown into or against a rock surface. It is similar to sand blasting operation. Wow. The wind act The wind action creates a number of interesting erosion and depositional features in the desert. In fact, many features of the desert owe their formation to the mass wasting and the running water as as sheet flood. Though rain is scarce in desert, it comes down to torrential, torrentially in a short period of time. Comes down torrentially in a short period of time. The, the desert rock devoid of vegetation exposed to mechanical and chemical weathering process due to drastic uh, dew, uh, dew, diurnal temperature changes. Decay faster and torrential rain help in removing the weathered rock material easily. That means, let read it once again. The desert rock, devoid of vegetation, get exposed to the mechanical and chemical weathering process due to drastic temperature changes. Decay faster and torrential rain help removing the weathered material easily. Okay, got it. That means the weathered debris in the desert is moving by not only the wind but also by the rain wash sheet wash. The wind moved the fine particles of materials, and generally mass erosion is accomplished mainly through sheet flood and sheet wash. Stream channel in desert are broad, smooth, indefinite, and flow for a brief time after rain. Are broad, smooth, and indefinite, and flow for a brief time after rain. Erosional landform, pediment and pediplains. Landscape evolution in desert is primarily concerned with formation of extension of pediments. Gen- gently inclined gently inclined rocky floor closely to the mountain at their foot with or without a thin cover of debris are called pediments. Such rocky floor from such forms through erosion of mountain front through a combination of lateral erosion by stream or sheet flood. So basically it is saying that, imagine this is the foot. So eventually, okay, not like this. This opposite of what I, basically like this. Imagine this is a rock in the desert, and its foot. This is the foot of the rock. Okay, it get erodes due to flood, sheet sheet flood, and also due to wind, which is carrying material, small materials are mountain, but like small particles, and this area is called pediment. So that is called gently inclined rock flow closely to the. So it is gently inclined. It is gently inclined. Why? Because it got eroded, and due to erosion, it is inclined at an angle close to the mountain or at their foot with or without a thin cover of debris are called pediments. Such rocky floors forms through erosion of mountain front through combination of lateral erosion by stream or sheet flooding. Erosion will start along the steep margin of land mass or the steep side of tectonically controlled steep incision features over the landmass. One pediments are formed with steep wash slope followed by a cliff or free facing above it. The steep wash slope and free face retreats backward. This method of erosion is termed as parallel retreat of flow and through back wasting. So through parallel retreat of flow, the pediment extend backward at the expense of mountain front, and gradually the mountain get reduced, leaving an in leaving an Selberg, which is a remnant of the mountain. This is how high relief in desert area is reduced to low feature plain called pedipalp plain. So basically it's saying that after a brief amount of time or erosion, it 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 goes on eroding. This part goes on eroding. Okay, and after it will go down after such an angle. This part will go down, and again this when this part goes down, its foot will again get eroded due to time. So, and after like centuries and centuries, this will eventually eroded into small plains, like smaller plains, into smaller plains, and these type of plains are called pediplains, which is that's how high relief in desert area is reduced to low feature. Like it will be a low feature plane called pediplane. Okay, let's go. Planes are by planes are what is playas? Playas. Next is playas. Plains are by far the most prominent landform in the deserts. In basin with mountain and hills around and along the drainages toward the center of the basin, and due to gradual deposition of sediments from the basin margins nearly level plain forms at the center of the basin. In times sufficient water in times of sufficient water, this plain is covered by a shallow water body. Such plain such type of shallow lakes are called playas, where water are retained only for a short duration due to evaporation, and quite often the piers contain good deposition of salt. The piers plain covered up by salt is called alkali flats. So it is saying basically that imagine this is a mountain valley and this is the basin, the base. This is the basin. So this is the water which got accumulated in the rainy due to rain. And when this water gets evaporate, due to heat in desert. So it leaves behind some deposits. Sometimes these deposits are mainly salt. So these kind of salt, sometimes the deposit are salt. So these type of salt, these are type. So basically it is a plain, but due to mountains around it or the valley around it, the water doesn't get anywhere, and it got dried up by heat, and the salt which is left behind is called not the salt. This plain which has the salt is called alkali flat. The deflation also these are layers. Deflation hollow and cave. Weathered mantle from over the rock or the bare soil gets blown out of the precision movement of the wind current in one direction. This process may create shallow depression called deflation hollows. Deflation also create numerous small pits and cavities over the rock surface. The rock faces the rock faces suffer impact and abrasion of wind-borne sand, and the first shallow depression is called blow called a first depression called blowout are created, and some of the blowout becomes deeper and wider to be called caves. Now next is mushroom or table of pedestal rock. Many rock outcrop in the desert easily susceptible to wind deflation and abrasion are worn out quickly, leaving some remnant of resistant rock polished beautifully in the shape of mushroom with stalk slender stalk and broad and round pear-shaped cap above. Sometimes the top surface is broad like a tabletop, and quite often the remnants stand out like pedestal. Lest the erosion features carved out by the wind action and action of sheet flood. Depositional landform. So here depositional landform. The wind is a good sorted agent. Depending upon the velocity of ring and different size of grain are move along the flood by rolling and saltation and carried in suspension. And in this process of transportation itself, the material gets sorted. When the wind when the wind slowly and or begins to dry out, depending upon size of grain and their critical velocity, the grains will begin to settle. So in depositional landform made out by wind, good sorted good sorting of grain can be found. Since wind is there everywhere, and whenever there is a good source of sand with constant wind direction, depositional feature are arid region and can develop anywhere. Such are also sand dunes also depositional features. So dry hot desert are good place for sand dunes formation. Obstacles to initiate sand dune formation are equally important. There can be a great variety of dunes formation. Okay, these are like types of dunes: Bachan, parabolic, and this is transverse and longitudinal types of sand dune. So here is the arrow indicating the direction of the wind. Crescent-shaped dunes are called Birchans, with the point of the wings directed away from the direction downwind where the wind direction is constant and moderate, and where the original surface over which the sand is moving is almost uniform. Parabolic dune forms when the sandy surface are partially covered with vegetation. That means parabolic dunes are reverse Birchan with wind direction being the same. Sheaf. Sheaf is similar to Birchan with small difference. Sheaf has only one wings or point. This happens when there is a shift in wind condition. The long wings, the long wings in Sheaf can grow very long, and longitudinal dunes forms when supply of sand is poor and wind direction is constant. They appear as long ridges of considerable length but low in height. Transfer dunes are aligned perpendicular to wind direction. These dunes forms when the wind direction is constant and the source of the sand is an elongated feature at right angle to the wind direction. They may be very long and low in height. Sand is plenty quite often. The regular shaped dunes coalesces and loses their individual characteristics. Most of the dunes in the desert shift, and a few of them will get stabilized, especially near human habitation. Wow, the end. This is a very, very, very long chapter. Which of the following stages of landform development downcutting dominates? So downcutting it dominates in the youth section. I've seen somewhere here. Not where is the youth? The youth is not here. Okay, this is the youth. Yes. In the earlier stages, downcutting dominates during which irregularities such as waterfall cascade will be removed. So answer is youth, not early mature. It's the youth stage. A deep valley characterized by steep like step-like side slope is known as a canyon. George is like this, where the opening is equal to the bottom. U-shaped valley will be like this. This is the U-shaped valley, and canyon will be like step-like. And these parts are called terrace. So, oh wow. So what is the next one? Which of the following region the chemical weathering process is dominant than the mechanical process? Not the glacier, it is mechanical. Arid region is also mechanical. Humid region humid region also mechanical due to what the water cuts the landforms. But in the limestone is made of calcium carbonate. Yes, it is made of calcium carbonate that reacts with the carbon in water, in rainwater. So the limestone region it reacts with water, and that reaction is a chemical weathering process. Which one of the following sentence best define the lapis? Hmm. Lapis. Let's see. The lapis. here, not here, not here. Kex, it is above Kex. Yeah. Okay. The shallow hollow. So the answer might comes under calcium carbonate. As I found lapis will be somewhere here. Okay, gradually most of the surface of limestone get eaten away by these wet trenches, leaving extremely irregular with a maze of points, grooves, ridges or lapis. Especially these ridges or lapis formed due to differential solution activity along parallel to subparallel joints. The lapis field may eventually turn into somewhat called smooth pavement. So lapis are irregular surfaces on the, let's see, irregular surface with sharp pinnacles groove. Yes, this is exactly landform which operate in more circular at the top. No, the landform formed due to dripping of water. This is that something stalagmite, yeah, stalagmite or something like that. It's maglactite. It's maglactite. A small bit to medium show of depression. No, irregular surface with sharp pinnacles or grooves or ridges. A deep deep, long and wide throat, a basin with steep concave high walls, and his head at his head as well as in the side is known as very steep concave wall at his head as well as at the side is known as this is so I have to read this. Let's see. Here are the most common landforming agitated creeks quite often found at the head of glacial valley. The accumulated ice cut these creeks while moving down the mountain top. They are long, wide, broad basin with steep, concave, vertically dropping. Yeah, exactly. So these are creeks. What do incised meanders rocky and in rocks and meanders in the plane of alluvial indicates? So basically these are in hard rocks. Incised meanders are in hard rocks. And the meanders in the alluvial indicates in sedimentary. Wow. Explain the evolution of valley sink or uvals. Underground, underground flow of water is more common than the surface runoff. Yeah, this is more common. Basically, what is happening? The the limestone. No. The limestone are porous in nature. Basically, porous in nature are and are quick to absorb water, which eventually are carried eventually carried downward due to gravity. Hence, hence, hence the underground flow of water is more common than the surface water. So limestones are quick to absorb water, and which eventually, yes, this is the hence the answer. Glacial valley shows up many linear depositional form. Give the location and names. Give their location and names. Oh, this one is. I have to see the diagram and answer these questions. Answer this question. Does the wind perform in? What does the wind perform? Its, how does the wind perform its tasks in the desert areas? Is it the only agent responsible for regional? No, it is not the only agent. The stream of water or sheet water or flooding water is also responsible. How does the wind perform? The wind carries the minute particle of sand which act as a bracing material that cause erosion to harder rocks or the or the mountain's foot, which also cause pediment. So yeah, this is answerable. Running water is far most dominating geomorphic agent in shaping Earth's surface in humid as well as in arid climate. Explain. So with this, your chapter is done.